Okay, now we are going to look at why we need the SOC. Okay, why it is SOC? Okay, first is, okay, the current CMOS is able to implement a complete system on one IC. Okay, means that we have the technologies. Okay, the technology, we have the current technologies. We have in which this technology, okay, can embed all of the component inside of one IC. So why not we use that technologies, okay, to implement all of the circuits, okay, all of the logic gates in the single ICs. Okay, so by applying this technologies here, okay, so it will the lower cost per gate. Okay, so this is the apa ni, result. Okay, once you already have all of the component inside of one IC, so what happen here is the number of gates that you're going to use is lower or small compared to if you need to have the different IC, okay, to make a system. Okay, so that's in that way. What happened here is, okay, you are going to use a lot of gates, okay, to for each for each of the ICs. But now we only have one IC, so the cost will be smaller compared to if you have several ICs and then you to make a one system. Okay, and it has a lower power consumption. Okay, of course lah, because you only have one ICs. Okay, so no need to power up the other ICs. Okay, because you only use a single ICs. Okay, if not, what happen is, okay, to if you are using the traditional or previous technologies, what happen is, for example, okay, you have the microprocessors, okay, and then you have the memories, okay, another IC for the memories, another IC for the microprocessor, and another IC for control lah. You're going to do an analog to digital converter, okay, ADCs. Okay, so what happened here is, okay, you have three ICs, okay, which is you're going to do the analog to digital conversion, and these three ICs need different power consumption. So what happened here is, okay, you need to power up all of these ketiga IC. So the power consumption might be uh, tinggi lah, okay, higher compared to, okay, if you're using a SOC, all of the microprocessors, the ADCs, and memory already inside of your ICs. So what happened? You only need to power up single IC compared to tadi, you need to power up three ICs. Okay, and it has a faster overall circuit and system operation, of course lah, because all of the components are inside the same ICs, okay, the same place. Okay, so the communication become more faster, okay, smaller physical size and more reliable implementation and design security. So that's why we need to opt for the system on chip, okay, the SOC. Okay, next, moving on to the platform-based design. Okay, so this platform-based design is actually one of the design methodologies that is implemented to avoid designing a chip from a scratch. Okay, so the platform-based design is a methodology lah in order to design a chip. Okay, and this platform-based design is used, okay, to avoid you design your chip from the scratch. Okay, and actually the platform, okay, is a library of components. Okay, you have a platform. Okay, so this is a platform. Inside of this platform, you have a library of components. Okay, so this library of components that can be assembled to generate a system. Okay, you have a library. Okay, from this library, you can pick whatever libraries that you need to make a system that you want. Okay, so this library, inside of this library, not only contains of computational blocks, okay, it have a computational blocks that carry out the appropriate computation, but also have the communication components, okay, that are used to interconnect the function kernel of the components. Okay, so this component library also known as the IPs. Okay, so component dalam library ni, which is inside of this platform, we name it or also known as a IP, which is another name for the intellectual properties. Okay, so actually the platform-based design is a family of architecture that specify a set of architectural constraints imposed to allow the reuse of hardware and software component. Okay, means that you can reuse this library component to make your system. Okay, to design the system. Okay, so the advantage of this platform-based design is fast time to market. Okay, why is fast time to market? Okay, because you no longer need to design the IC or the chip from the scratch. Okay, so that's why it's the fast time to market. Okay, the time to design is shorter. Okay, then okay, you can reuse system design, which is you can reuse the hardware, you can reuse the software. Okay, and allow chip to be customized to add value. Okay, you can customize your chip, okay, from these libraries here. Okay, you can pick anything that you want, okay, that inside of this library. Okay, so that is the platform-based design. So this is actually a design methodologies lah to design your system or to design your ICs. Okay, so this is an evolution for the design methodologies. Okay, we started with the ASIC. Okay, the ASIC is actually A is a stand for the application, S is specific, I integrated, C is a circuit. So it is a microchip designed for a special application. Okay, you can see here. Okay, it uses the logics to design the ICs. Okay, so this ASIC is a timing-driven design. Okay, then after that, the block-based design was introduced. Okay, which is you're going to design a complex ASIC with a few IPs. Okay, you have this SIC and then tambah dengan a few IPs, intellectual properties here. Okay, such as RAM, ROM, microprocessor core to your logic design. Okay, then after that, okay, the platform-based design was introduced, which is use the plug and play SOC. Okay, so you can see you have a lot of IPs that you can pick from these libraries here. Okay, the components library to your designs. Okay, to your SOC designs. Okay, so this is the evolution of the design methodology. Okay, you can find the more details on this part here in this book. Okay, Surviving the SOC Revolution, a guide to platform-based design. Okay, so here are the list of the IP blocks that are used today. Okay, first we look at the first IP block, which is a processor cores. Okay, inside of this processor cores, it has the ARM IPs, MIPS, PowerPC, Sparks. Okay, all of the processor are inside of this processor core. Okay, you can pick whatever processor that you're going to use. Okay, then we have the interface blocks. Okay, which is this is for the communication lah. Okay, you have the USB, PCI, UART, and Rambus. Okay, so you can choose any communication interface to your designs. And then for the encryption, okay, so this is for the data security. Okay, it has the IP block for the DES and AES. Okay, while if you're going to make a system on chip with a multimedia, okay, you can put a block, IP block for the JPEG coder, MPEG decoder, H264 decoder. So this is for ni lah. Okay, yang ni untuk gambar. Okay, JPEG is for the gambar, and this is for video. Okay, so if you're going to have the camera inside of your system, okay, you can put these blocks, okay, in your design. Okay, for the networking, okay, we have the ATM switch and Ethernet. Okay, so this is for the networking. DSP, okay, you can pilih either you're going to use the OP, TI, or SHARP. And meantime, next, okay, if you're going to have the real-time operating system, okay, you can choose this blocks here, okay, VxWorks or QNX. Okay, so this is the IP blocks that commonly used in today's SoC, okay, system on chips. Okay, and now we are going to look at the example of system on chip. Okay, we have a lot of system on chip in the market nowadays. Okay, now we're going to look at the examples. Okay, the first one here, okay, we're going to look at the Snapdragon Qualcomm. Okay, so Qualcomm is one of the manufacturer, okay, that produce the system on chip based mobile processor for the smartphone. Okay, every time you hear the word Qualcomm, okay, you know that this one here designed the SoC for the smartphone. Okay, so inside of this chip here, okay, inside of this small chip, it can have the CPU, okay, the what we call it, central processing units, okay, and then it also have the GPUs, okay, digital signal processors, okay, which is used to process your audio, process your any digital signals, and then if you have the video, okay, if your smartphone come with camera, okay, it will have the image signal processor inside of this chip as well, and RF processor. Okay, so this is for itulah RF technologies. Okay, so the processor transmit and receive the data among themselves via bus-based system or interconnect fabrics. Okay, which is a network on chips. Okay, buses. Okay, so this is the examples of the SoC. Okay, used in the smartphone. And then we have the Intel Atom SoC. Okay, Z2580. So this Intel Atom Z2580 is a mobile or notebook SoC processor. Okay, you can find this processor inside of the mobile as well as inside of the notebook. Okay, so you can see here inside of this chip, it has the CPU. Okay, mana dia punya CPU? Okay, it have the CPU. Okay, so this is the CPU, 32-bit CPU if not mistaken. Okay, then it have the graphical processor unit or integrated graphics. Okay, GPU. Okay, and it have the video encoder and decoder. Okay, so see here, video decoder, okay, which is to decode a video at 1080 pixels, and video encode, okay, 1080 pixels. Okay, and it have the image signal processor, okay, which is here, image signal processors, and video image enhancer. Okay, to enhance the video, it have another what we call here, blocks to do that. Okay, components to do that, and others such as the SPI, UR, and etc. Okay, so this is inside of the Intel Atom SoC. Okay, inside of this single chip, inside of this IC here, consists all of these components. Okay, all of these what called IPs. Okay, then we move on to the Intel Atom Z3000. Okay, so this is an Android tablet system on chip processor. Okay, so inside of the Android tablet, you may find this Intel Atom Z3000. Okay, so inside of this one here, you have the processors. Okay, so this is the processors. Okay, maybe it's a quad core 1, 2, 3, 4. Is it? Yeah. And then it have the GPU, integrated graphical units. Okay, here. Okay, you can see Intel HD graphics, and it also have the video decode engine. Okay, display controller, image processors. Okay, and for the here you can see it support the HDMI inside here. Okay, and then for the image processor, next we have the Wi-Fi, okay, USB, okay, and etc. Okay, so this is inside of the Intel Atom Z3000 chip. Okay, you have all of these components inside of the single small chips. Okay, then this is for the Intel Quad SOC 1000. Okay, this is a small chip here. Okay, inside of this chip here, you can see it have these processors, okay, PCIe's, DDR3, okay, RAMs, and then you have the legacy blocks here, and then these what communication protocols here. Yes, so that is for what we call here system on chip. Okay, any question up until here? Okay, our activity one. Okay, I'm going to I want you. Oh, sekejap ya. Okay, so this is for the iPhone 13 Pro Max. Okay, using the Apple A15 Bionics system on chip. Okay, so let's look at the what we call here the specs. Okay, what inside of this ICs here. Okay, so it has the Quad HD plus in terms of the display. Okay, it can support a Quad HD plus. Okay, and then for the cameras. Okay, so it have the sensors. Okay, for the with a 12 megapixel sensors and 12 another 12 megapixel sensor for the single camera and a 12 megapixels camera for the dual camera. And for the storage inside of that chip also have the storage which is use the LPD DDR5. Okay, and in terms of the CPU and GPU, okay, so this Apple 15, okay, this chip here, okay, Apple A15 Bionics here have the CPU, okay, which is you can see it have a 6-core CPU, okay, one CPU, okay, have a 2 cores called as Avalanche, okay, which is a speed of 3.2 gigahertz. So kat dalam ni, okay, you have two what we call here two processors lah, okay, central processor. One is Avalanche, okay, which is have a 2 cores, speed 3.2, and then the other one is Blizzard, okay, 4 cores Blizzard with a speed of 1.8 gigahertz, and it also have the GPU, okay, with a name Apple Custom Quad Core GPU. Okay, so in terms of the networks, okay, so it have the 5G bands inside of that chips, and also this for the modem for GLT like 24. Okay, instead of 5G, it also can support this band here. Okay, and yes, it has the NFC. Okay, near field. Okay, sorry, I need to take a call first. The same chip. Okay, and then it can support the Wi-Fi 6. Okay, NFC, other near field. Okay, NFC here, and GPS, and doesn't have the FM radio. Okay, so this is for the Apple A15 Bionics. Okay, and then moving on to the Samsung. Okay, now we have the new Samsung phone coming out called the Samsung S22 Ultra. Okay, now we're going to look at what is inside. Okay, what are the system on chip used inside of the Samsung S22 Ultra. Okay, so for this one here, okay, for the Samsung, okay, it use the Snapdragon 8 Gen 1 mobile platform. Okay, so this inside of this chip here, okay, you may find all these things. Okay, dia ada banyak benda kat sini. Okay, you can see. it has the GPU, CPU. Okay, the GPU used here is Qualcomm Adreno GPU, and CPU is Qualcomm Cairo CPU. Okay, later we'll see more details on this GPU and CPU, how many cores that you have. Okay, and for the CPU, okay, you can see here. Okay, the CPU's clock is at 3.0 gigahertz. Okay, and then it's a 64-bit architecture. Okay, and then regarding the cellular modem RF, using the Snapdragon X65 5G modern RF system. So inside of the same IC have this RF module, and then it also have this Wi-Fi modules. Okay, while using the Qualcomm Fast Connect 6900 here. Okay, and also have the Bluetooth. Okay, the GPRS. Okay, using the GLONASS. Okay, and all this thing here. Okay, near field communication also supported. Have a USB, and for the camera, okay, it has this Qualcomm Spectra image signal processor inside it. Okay, which is support 3 cameras here. Okay, you can see a triple camera up. Okay, using these sensors here, which is up to 36 megapixel sensors. For the dual camera, up to 64 and 36 megapixel sensors, and for the single camera, up to 108 megapixel sensors. Okay, so this is for the image signal processors. Okay, regarding the video playbacks, okay, so it have this what we call here codecs here. Okay, you can see it have the AVC, HEVC, etc. Okay, and this for the display. Okay, inside of the same IC, it have this display here. Okay, the module for the display, audio, and GPU. Okay, you can see the GPU is using the Qualcomm Adreno GPU. Okay, and security. Okay, it has a biometric authentication. Okay, which is it have a fingerprints. Okay, iris and voice and face recognition inside of the same ICs. Okay, inside of that Qualcomm Snapdragon 8 Gen ICs. And regarding the memories, okay, it's used the LPDDR5 memories. Okay, with a speed of 3,200 megahertz, and all of these things lah. Okay, so this is inside of this chip here. Okay, this SoC called a Snapdragon 8 Gen. Okay, so this is inside of the Samsung S22 Ultra. Okay, so that is for the system on chip. Okay, you can see now inside of the single chip, it have a few modules, okay, integrated, okay, so that the device become more small. Okay, the chip is smaller, but you can fix more module or more IPs inside of the one single chip. Okay, any question up until here for the what we call system on chips, SoC? Ada soalan tak? Do you have any question on the SoC? Okay, if no question, okay, now we're going to look at this high-level language programming. Okay, kita masuk sikit je in this high-level language programming. Okay, so this is the reason lah kenapa why we need to use the C programming. Okay, not the assembly language and not others language. Okay, so compared to assembler, it's fairly efficient. Okay, more efficient compared to assembler. It provides an additional level above assembly language because it's a high level language. Okay, so easy to use and easy to understand. Okay, it can support access to input-output, of course lah. If you're using the assembly, it also support the input-output. But okay, you need to know the registers names and what we call here the address of the input-output. ports, okay? Compared to C programming, you don't need to know the hardware parts, okay? You just use the variable, okay? And the compiler will automatically choose which register that it's going to use. Compared to the what we call here assembly language, okay? Assembly language, you have the control lah, nak guna which register that you're going to use, okay? Which input output port that you're going to use, okay? What type of addressing mode that you're going to use. But for the C programming, okay, that one will be chosen by the compiler, okay? Ease of management of a large embedded projects, okay? And another reason here is simple to write compiler, okay, which is a programming embedded system often only have a C compiler, okay? So yes, a C programming have a C compiler, and it have an existing open source code, okay? You can use a Linux, okay, to write in C programming. Okay, if you doesn't have any C compiler, okay, you can use Linux. Simply write the inside of the Linux, then you can run your programs. Okay, so this is the reason lah kenapa kita kena guna C programming. Okay, so what do we need to know? Okay, in the C programming. Okay, first, okay, you need to know how to perform the input output in C. Okay, how to initialize the input output port, how to send a value to the output, how to read the value from inputs. In the meantime, okay, you need to know how to do a bit manipulation instruction. Okay, because it is involved the input output. Okay, you need to do some bit manipulation. Okay, from your inputs or from your output. Contoh lah, okay, you're connected your switches, okay, to port A pin number 3. So how you going to do a bit manipulation so that you read the correct switches, okay, which is that is connect to the port B pin number C, not any other port. Okay, so that's why you need to know how to do the bit manipulation so that you can read or you can write the correct input output values. Okay, and how to do the addressing in an I/O device in C. Okay, so here you need to know lah as well. And then the pointer arithmetics, how to do the arithmetics, okay, tambah tolak bahagi darab, and the compiler option, okay, to generate optimized code. Okay, so you need how to make your code more simple, okay, more optimized, and how to debug your code if there is a error. Okay, so this is the things that you need to know. Okay, moving on to this slide here. Okay, so this is the basic structure of the C5. Okay, kamu dah belajar benda ni sebelum ni in the microprocessor class and in your year 1 C program kalau tak silap saya. Okay, classes. Okay, so first you need to, okay, started with the command lah about the file. Okay, you need to, every time you write the program, okay, make sure that you put a comment about what you're going to write. Okay, so that when other people, okay, going to read your program, okay, he know that, okay, so this program here is going to do this thing, and that program is going to do the other things. Okay, first, okay, this is the very basic stuff. Okay, this is the very first thing here. Okay, you need to have this include and define. Okay, you need to include the file, okay, inside of your program, or include any libraries inside of your program that you're going to use, and any defines must be put here. Okay, so but you can use it by using the hashtag include, okay, to include any libraries, to include any file to your program. And to define, you can use the hashtag define. Contoh macam sini, port base sama dengan OX 40000 means that, okay, you define the address of port base dekat this address. Okay, so this is how to do the addressings lah in C programming. Okay, but don't be afraid because we have the file, okay, that already define all of the input, output, and register addresses. Okay, so no need to hafal to memorize all of the addresses of input output ports. Tak perlu. Sebab kita ada one file. Once you call that file, okay, so you can simply use the name, okay, to use your input output port ataupun to use your your registers. Okay, we don't need to define the addresses of that input output ports anymore. Okay, then followed by the function prototype and global variable declaration. Okay, all the function prototype, all the global variable declaration must be put here. Okay, contohlah kalau kamu ada a few functions. Okay, so after you include the find and define here, okay, make sure that you include all of the function that you use in your program. Okay, so such void main void, void your function void, and etc. Okay, if you not put here, what happened here is the compiler might not data kenal lah. Okay, it cannot what you call kenal your function after you use down here. Okay, kat bawah ni, when you use down here, it will not recognize that function. Okay, so to be safe, okay, better you declare your function, all the function prototypes or global variables you need to declare it here. Okay, then followed by the main function. Of course lah, you have the main function. Main function is your main programs. Okay, started with your this main void. Okay, and then followed by all the things lah that you need to write down inside of your main programs. Okay, and then if you have a several function, then after that you can put, okay, you can write down your functions, okay, after your main program. So every time you call your function here, it will go automatically to this function subroutine. So this is the basic structure of the C file. Okay, and this is embedded. Okay, this is the how you're going to write a C program that never end. Means that it will loop continuously. Okay, to do it, okay, you can use either while or for loop. Okay, for the while loop, okay, to make it loops continuously or forever, okay, you can put while one. Means that it always okay, this condition always true. Okay, when the condition is always true, it will keep repeating. Whatever inside here will keep doing until you shut down your compiler atau you shut down your programs. Okay, so it will keep repeating. This is how you're going to make it so that it will do it continuously. Or for the for loop, okay, you just simply write something like this: for followed by bracket and followed by this semicolon. Okay, no need to put the condition inside here. Jangan letak condition. Any condition no need to put here. Okay, sebelum ni kan kita buat int I sama dengan kosong, and then I is smaller than 10, I plus plus. Okay, no need to write this thing inside here because you're going to do it continuously. So tak perlu. Okay, no need to do it. Okay, so when you put something like this, it will do it continuously and forever until you stop the program. Okay, so this is how to make a program that never ends. Okay, by using a while loop ataupun by using a for loop. Okay, without any condition inside here. Okay, then we look at the testing value. Okay, because we're using a C, okay, we need to do some bit manipulation and bit testing, okay, to do our program. Okay, so in C, conditions are evaluated on the basis of 0 and non-zero. Okay, so dia hanya kita akan hanya lihat either the condition produce a zero value or a non-zero. Okay, for example, okay, the quantity 088T, okay, so this is a non-zero. Kenapa non-zero? Because you have the values here. And therefore, this condition is true. Okay, but sometimes it depends on the way you program lah. Other the way you program, the non-zero will give you, okay, or will yield the condition true, ataupun sometimes a zero will give you a condition true, but it is depend on your programming actually. Okay, so these are the valid expression. Okay, some are not useful but still valid. Okay, for example, okay, you're going to compare A with any number. So you can put if A greater than 3. Okay, so when this A is greater than 3, then the condition is met, means that the condition is true lah. If not, what happened? Okay, the condition is false. Okay, and if you want to have the two condition, okay, you're going to check two condition. Okay, you can put if A greater than B, and this n symbol means that you need to check first. Is it this one is true? Okay, and then the second one, you need to check is it this one also true. If both condition is met, then what happen? The condition is true because you have this logical and. You see here, this is symbol for the and. Okay, this is an and symbol for the logical and. Okay, so you need to check whether both condition is true or not. If both condition is true, then the final condition is true lah. So you do the things inside of any coding after this if statement. If not, then you exit from your if else statement, okay, and do other thing. Okay, if one of this condition is true, what happen? Because due to this and, so what happen? This one become false. Okay, another one here. If one, okay, means that this one always true. Okay, so this is a useless lah. So no need to put this thing also. It will execute the next blocks. Okay, it will execute the instruction after this. Okay, because it always one. Okay, if you put if 0, okay, means that it always false. Okay, whatever you put down here, okay, will not be executed. Okay, so this is another useless things lah. Okay, if you put if 3 check, okay, this is an OR with 6. Okay, and you can see here it always execute. Why? Because 3 you have value, 6 also have value, and both will produce a 1. Okay, so it will always execute. So this 3 here is a useless punya expressions lah. Okay. Next, okay, if you're going to check whether this value here equal to n values. Okay, so you can put if A equal 0. Okay, you're going to check here. Adakah A sama dengan kosong? Okay, so if A sama dengan kosong, what happen? Do the next instruction. If not, it will exit from this if else instruction. Okay, what about this one here? Okay, so this is similar to this one. If okay, A is not 0, means that your A have value. So it will execute the next blocks. Okay, it's something like this lah kalau kita buat flowchart. Okay, sorry. Adakah A sama dengan kosong? Okay, kalau yes, okay, it will go here. If no, it will go here. Okay, so this one also same lah. Adakah A sama dengan kosong. Check whether A sama kosong. If yes, go down here. If not, it will go here. Okay, and what about this one here? If A sama dengan kosong, means that you define your A sama dengan kosong. This is not a condition lah. Kamu define. Okay, you will change your A, the value of A equal to 0. Okay, and this is the better way lah to check. If 0 equal to A, okay, A is actually sama dengan yang atas. Selalu kita pakai yang atas ni. Okay, rather than the yang bawah. But this one is a better way lah to check sama ada A is equal to 0. Okay, so this is how to testing the value, okay, by using this condition. Okay, depending on the condition. Okay, now we're going to look at a bit manipulation. Okay, so we have a few symbols here for the bit manipulation. Okay, the first one here is AND. Okay, so this AND here is for the logical AND. Okay, whatever you do it, okay, you need to check your AND truth table lah. Okay, which is kamu dah pernah belajar. Okay, so for the AND truth table, so this is for the AND 0 0 0 0 1 0 1 0 is a 0 1 1 is 1. Okay, so this is for the logical AND. And then what about this vertical line here? Okay, so this is for the logical OR. Okay, so when 0 OR with 0, you will get 0. So this is 1, 1, and 1. Okay, and how about this symbol? Okay, so this is for the exclusive OR. Okay, so you need to know lah, what is the exclusive OR? Okay, the exclusive OR says that, okay, so when 0, 0 is a 0, this is a 1, 1, 0. Okay, means that if both value are same, okay, the output will be 0. If one of the value is different, the output will be 1. And this one here, this is for the left shifting, and this is for the right shifting. Okay, you're going to shift to the left, depending how many bits that you're going to shift here lah, kat sini. Okay, right shifting also same. Okay, how many bits you're going to shift? Is it 3 bit, 4 bit, or etc.? Okay, and this one here, this theta here is for the one complement. Means that you do the complement, do the NOT gate actually. Okay, if you input is 0, it will become 1. If your input is 1, and it will become 0. Okay, so let's look at this example here. So you have this value. A is 10, 10, 10. So A is a 8-bit data. Kamu ada 8-bit data. A is AA. B is 0F. Okay, if you translate this value here to 8-bit data, you will get this value. Okay, now we are going to do the first one is A and with B. Okay, means that you're going to do a logical AND A dengan B. Okay, so first you do lah the logical AND. 1 AND with 0. Okay, it will produce 0. Okay, based on this truth table here. 0, 0 dapat 0. 1, 0 is a 0. 0, 1, 0, 0 is a 0. 1, and with 1, you get 1. 0, 1, you get 0. 1, and with 1, you get 1. 0, 1, you get 0. Okay, and then the final answer will be 0A after you convert back to hexadecimal. Okay, next. Let's A logical OR B. Okay, you're going to do an OR with a B. So what happened here? 1, 0. Okay, it will produce 1. 0, 0, 0. 1, 0 is produce 1. 0, 0 is a 0. 1, 1, you get 1. 0, 1 is a 1. 1, 1 is a 1. 0, 1 is a 1. So you convert back to the what we call hexadecimal. Okay, so this one is 8421. Okay, you're using the 8421. So this one is a F. And 8 tambah 2 is a 10. 10 is a A. So you get AF. Okay, by using the 8421 method. Okay, if you doesn't have the calculator, okay, you use the 8421 method to obtain the hexadecimal number from binary numbers. Okay, and then this one here. So this one, you're going to do the exclusive OR. Okay, you can see here 1 0 exclusive OR with 0. Okay, you get 1 because both input are different. So 1 0 0 produce 0, 1 0 is a 1, 0 0 is a 0, 1 1 is a 0, 0 1 is 1, 1 1 is a 0, and 0 1 is a 1. Okay, then you change to what we call here hexadecimal. So this one here 8 tambah 2 is a 10, and this is a 4 plus 1 is a 5. So you will get a 5. Okay, what about this one? Means that, okay, you're going to shift to the left. How many times? How many bits? 1 bit. Okay, so you just take your A. So this is your A, 1 0 1 0 1 0 1 0 1 0. Okay, shift to the right. How many times? 1 time. Okay, so here you shift to the right 1 time. So it becomes 0 1 0 1 0 1 0 0. Okay, change to what we call here hexadecimal. Then you get 4 tambah 1 is a 5. This is 4. So you will get 5 4. Okay, and what about this, the second one? Okay, so this one here, okay, the second one is B, shift to the right how many times? Okay, you're going to shift to the right 2 times. So what you're going to do? Okay, sama juga. Okay, you take the B value. So this is a B 0 0 0 0 1 1 1 1. Okay, so now you're going to shift ke mana? Ke kanan. How many times? 2 times. Okay, so what happened here is, okay, we started from here lah. Okay, so 1 2. Okay, so you'll get 0 0, yang lain semua shift lah to the left, to the right, but 2 times. 0 0 1 1. What about here? Okay, so you fill up with 0, and this one here will go outside of your bits, so you will get kosong. Okay, so this is a 0 3. Okay, so you get kosong 3. And last but not least, okay, the last one here is complements. Okay, this tilde B means that you're going to invert your B. Okay, so 0 become 1, 1 become 0. Since this is a 0F, okay, so automatically lah, you know, after you do the inversion, okay, you invert the value, you will get F0. So that's why you get F0. Okay, any question up until here? Ada soalan tak? Okay, if no question, I think we stop here. Okay, next week we continue with a concatenating bits. Okay, so thank you guys. See you next week.